Hello, I'm Brian Farrell, and welcome to session on the network cabling part 1. Today we're going to be talking about twisted pair network cabling, then we're going to talk about twisted pair network connectors, and then we will conclude with categories of twisted pair. I have a whole lot of information to cover and I need to get through this quickly, so let's go ahead and begin this session. And we'll begin by talking about twisted pair network cabling. Most people are familiar with twisted pair cables because they are the standard in the modern LAN. They are what you see most often when you're looking at network cabling. Twisted pair cables are composed of 4 pairs of wires contained within an insulating sheath. Each pair of wires is twisted together to reduce electromagnetic interference, which is called EMI. The twist rates differ between the pairs to reduce crosstalk between the pairs, which is a type of EMI. The colors of the pairs of wires are always white orange orange, white blue blue, white green green, and white brown brown. Twisted pair network cabling comes in either unshielded or shielded twisted pair. That would be UTP or STP. The difference is that STP has an additional shield that is either wrapped around each pair of wires or around all 4 pairs of wires. That shielding reduces the opportunity for EMI or crosstalk, but it is more expensive and a little harder to work with because it's not as flexible. UTP, or unshielded twisted pair, is deployed in the network much more often than STP. There are also plenum and non-plenum types of twisted pair. Most twisted pair cabling is non-plenum grade, but building codes often call for plenum grade cable to be run in plenum spaces. Now, a plenum space is that area that is designed to assist in the airflow of a building for HVAC purposes. And most often, the plenum is that space between the false ceiling and the actual ceiling. Plenum cable is jacketed in either a fire retardant cover or in a low smoke PVC jacket. Plenum cables often have a polymer or nylon strand woven into the cabling or into the jacket to help take the weight of hanging cables. This reduces the chance for the cable to stretch, which can cause the pair or pairs of wires inside the jacket to break. Twisted pair is usually either a straight-through cable or a crossover cable, but it can also be used to create a rollover or console cable. A straight-through cable is used to connect different types of devices together, as in a computer to a switch or a switch to a router. While a crossover cable is used to connect similar devices together, as in a PC to a PC or a switch to a switch. The straight-through and crossover cable use different pinouts to achieve their connections. A rollover or console cable is often required to connect to the console port on a switch or a router. It is quite common for one end of the rollover cable to use an RJ45 connector, while the other end utilizes an RS232, also called a DB9 connector. So now that I've mentioned those connectors, let's go on to twisted pair network connectors. And we're going to begin with the RJ11. You don't see these very much in what we think of as networking, but you do see them all the time. The RJ11 uses a 6-position, 4-contact modular connector. That's a 6P4C modular connector. It can carry data or voice, and its common usage is voice communication, telephony. All of your telephone jacks are RJ11s. Then there's the RJ45. This is the one that we always think about when we think about networking with twisted pair cabling. It uses an 8-position, 8-contact, or 8P, 8C modular connector. It can carry data or voice, and its common usage is data networking, Ethernet. Then there's the RJ48C. It also uses an 8-position, 8-contact modular connector, 8P8C, just like the RJ45. As a matter of fact, it's often thought of as being an RJ45. but it's used as the terminating connector at the demarc point for T1 lines. And as I said just a moment ago, it's often confused with the RJ45, but the active pins are different. Then we have the UTP coupler, the unshielded twisted pair coupler. It's used to connect UTP cables back to back and still maintain adherence to industry standards. You might still come across a 66 block being used for network connections, but probably not. It's a punch-down block that was initially developed to terminate and distribute telephone lines in an enterprise network. So you might still see it for telephony, but it's getting a little bit harder to find it. It was also used in slower speed networks as it can handle data traffic that's rated for Cat3 cabling. Much more likely you'll find a 110 block. Now this is a punch-down block that was developed to terminate and distribute twisted pair network cabling. It's capable of handling the signaling requirements of the modern network. I mentioned the DB9 or RS232 connector earlier. Well, here we go. It is a 9-pin D-subminiature connector developed for asynchronous serial communication between nodes. It was a common type of connector between a computer and an external modem. And as I said earlier, it often makes up one end of the rollover cable. You might come across a DB25, also known as an EIA 232 or RS232 serial connector. It is a 25-pin D-subminiature connector developed for asynchronous serial communication between nodes, just like the DB9, only it was larger. It too provided a type of connection between a computer and an external analog modem, and it's even less common than the DB9. Now let's move on to categories of twisted pair. And we begin with Cat3. Cat3 was rated for up to 10 megabits per second speed, that's 10 base T networking, and it had a maximum distance of 100 meters. By the way, unless I specify, all twisted pair cabling has a max distance of 100 meters. That 10 megabits per second wasn't quite fast enough, so then we got Cat5. Cat5 is rated for up to 100 megabits per second speed. That's 100 base T networking. And that still wasn't fast enough, so they developed Cat5e. Cat5e is rated for up to 1 gigabits per second. That's 1000 base T. Now we have Cat6. Cat6 is rated for up to 10 gigabits per second. That's 10 gigabit Ethernet or 10 GBE. And with Cat6, you can only get that 10 gigabits per second over a max distance of 55 meters. For some reason, they thought they needed to go more distance than 55 meters, so they developed Cat6a. It has the same speed ratings as Cat6, but it has a max distance of 100 meters, and you can still achieve that 10 gigabits per second networking. Now that concludes this session on network cabling part 1. I talked about twisted pair cabling, then I talked about twisted pair network connectors, and I concluded with the categories of twisted pair cabling. Network cabling part 2. Today we're going to be talking about coaxial cabling and fiber optic cabling. There's a fair amount of ground to cover, so let's go ahead and begin this session. And of course we're going to begin by talking about coaxial cabling. Coaxial, or coax, cabling is one of the oldest Ethernet standards for network cabling. It was standardized in 1973. It's been used for baseband, carries just a single digital signal, and it has been used for broadband, carrying multiple digital signals. It is composed of a central conductor that is covered by an insulating layer, which is covered by an outer mesh or foil layer, which is then finished off with an outer insulating layer. That inner metal mesh layer helps to protect against electromagnetic interference, EMI. There are several different types of coax cable. There is RG58. It was used in 10^2 networking. It could span a maximum distance of 185 meters and had a 50 ohms impedance value. It's no longer commonly found in the modern network. Then there's RG59. It's commonly used to provide a broadband connection between two devices over a short distance. And it has a 75 ohms impedance value. And it's only used for short distances because it leaks its signal. It can't span very far. Then we have RG6, which is used for cable TV or broadband. Now the distance that RG6 can span varies, but it still has a 75 ohms impedance value. And it's commonly used to make the connection to a cable modem by the cable company. There are two basic types of coax cable connectors. There is the BNC, also known as the bayonet Neal-Councilman connector. You can also call it a bayonet connector. It is used with coax cabling, but is now considered obsolete. The connection from the cable to the device was achieved through a spring-loaded twist lock type of connector. A BNC coupler can also be used to connect two coax cable segments back to back. Much more common is the F connector. It's a threaded bayonet connector, and it's also used with coax cable. An F connector coupler can be used to connect two coax cable segments back to back. Now let's move on to fiber optic cabling. So now let me describe fiber optic cabling. First off, it's relatively expensive and harder to work with than with other types of network cabling. It's not as common as other types, either coax or twisted pair, in the LAN environment. But it can resist all forms of electromagnetic interference, and it cannot be easily tapped into. That means it's harder for people to eavesdrop on your network transmissions. It also can cover long distances at high speed. Fiber optic cabling is designated by fiber type, cladding size. By the way, the cladding is what the light bounces down, and its jacket size, that outer jacket that covers the cable. The size of the cladding and the size of the jacket are listed in micrometers. Most applications of fiber optic cabling require that the cables be run in pairs. One cable to send transmissions, one cable to receive transmissions. The type of connector used on fiber optic cabling can impact the performance of the transmission. There are two basic categories of connectors. There is the UPC, the ultra physical contact. This connector has a back reflection rating of around a negative 55 decibel loss. Then there's the APC, the angled physical connector, which has a back reflection rating of around a negative 70 decibel loss, making it the better performing connector. Now let's talk about fiber types. There's multi-mode fiber, which uses an infrared LED system to transmit light down the fiber. It sends multiple rays of lights down the cable at the same time. It is used for shorter fiber runs, under 2 kilometers. It is less expensive than the other type of fiber cabling. Then we have single mode fiber, SMF. It uses a laser diode arrangement to transmit light down the fiber. It only sends a single ray of light down the cable. Even though my diagram depicts it as going straight, it still bounces down the cladding, but there's only one of them. It's used for longer runs that require high speed, and it can span more than 40 kilometers. So now let's talk about fiber optic cabling connectors. And first up is the SC. That is the subscriber connector or the square connector. You can also call it a standard connector. An easy way to remember it is stick and click. It's a push-pull type connector. Then we have the ST, the straight tip. You can also think of this as stick and twist. It is a spring-loaded twist lock type of connector. There is also the LC, which can be called the local connector or lucent connector or little connector. It's a type of connector that uses a locking tab to secure the connection. Similar to the LC is the MTRJ, the Mechanical Transfer Registered Jack. It's a small form factor connector that contains 2 fibers and that also utilizes a locking tab to secure the connection. You might also find a fiber optic coupler. Guess what it does? It's used to connect 2 fiber optic cables back to back. Now that concludes this session on network cabling part 2. I talked about coaxial cabling and I concluded with fiber optic cabling.